Making conducted EMI Precompliance measurements. EMI Precompliance measurements have been gaining in popularity. One of the main reasons for using EMI Precompliance is to gauge the conducted and radiated EMI performance of the DUT during the development phase in order to identify problems early so that they can be resolved before moving on to the next phase of development. The goal is to be able to pass testing at a fully accredited compliance test facility without additional changes and get the product to market on time and within budget. Today we are using the Agilent N9000A CXA signal analyzer and other necessary components to perform conducted EMI pre-compliance measurements for a DUT. In addition to the signal analyzer, other components are needed to complete the tests. One is a line impedance stabilization network, LISN. This component serves three purposes. 1. Isolate the power mains from the DUT. 2. Isolate any noise generated by the DUT from being coupled to the power mains. And 3. Couple the signal generated by the DUT to analyzer. The other component is a transient limiter. It protects the input of the analyzer from large transients when it's connected to a LISN. Switching the DUT's power on or off can cause large spikes to be generated in the LISN. Let's start the test. For this demonstration, we chose this PC as our DUT. Let's take a look at the connections between the devices. The power cord of LISN is connected to a well-grounded wall outlet. The power cord of the PC is connected to the power output port of the LISN. Connect the power cord of the CXA to a wall outlet that's well-grounded. Connect the RF input of the CXA to the limiter. Insert an RF cable into the other side port of the limiter, and connect the cable to the LISN. Before powering on the DUT, we usually want to test the base of the measurement system. This helps us understand if there are any unwanted emissions from the system other than those coming from the DUT. The test allows us to look at the analyzer's performance. Let's set the CXA signal analyzer. When we access the EMI receiver mode, we'll see the screen looks different from when the CXA is in the normal spectrum analysis mode. In EMI receiver mode, the analyzer is able to perform EMI pre-compliant measurements, which have CISPR 1611 compliant 6 dB bandwidth filters and selectable EMI detectors, including EMI average, quasi-peak, and peak detectors. In EMI receiver mode, the analyzer has predefined test ranges according to EMI standards. Here we choose range 2, 150 kHz to 30 MHz. Next, we recall the limit lines which are pre-installed in the instrument according to the EMC standards. In this case, we choose the EN55022 standard, which applies to PC. To do this, we first load the limit lines for the quasi-peak detector. Next, we load the limit lines for average detector. All of these limits comply with EN55022 standards. After loading the limit lines, we need to load the correction factors of the LISN and limiter. Note, we have pre-installed the correction factors file of the LISN, which we are using in this demonstration. If you want to load the custom correction factors of your LISN, you can easily edit it in the Correction Edit menu. We also have loaded the correction factors of the limiter used for this demonstration. Now we trigger the signal analyzer to start the sweep and we'll see the spectrum. There is no obvious high-level signal and the margin from the noise floor to the limit lines is fine. Now we power on the PC. We can see it's working now. Now we can start the conducted emission measurement of the PC. We know that limit 1 represents the limit when the signal is measured with quasi-peak detector, and limit 2 represents the limit when it's measured with an EMI average detector. The CXA signal analyzer allows us to measure the signal with up to 3 different detectors simultaneously and display the signal in 3 different traces. A different limit line can also be applied to each trace. This gives us the ability to set trace 1 to be measured with peak detector and set trace 2 to be measured with EMI average. We usually don't use quasi-peak detector directly when in signal scanning because it's very time-consuming. Instead, we use peak detector. The measured result in peak will never be lower than quasi-peak. Therefore, if a signal passes the quasi-peak limits with peak detector, it will always pass the limits with quasi-peak detector. The quasi-peak detector will be only used to measure those peak signals which fail the quasi-peak limits. We set limit 1 to test trace 1 and set limit 2 to test trace 2. You probably also noticed that the signal scanning process is slow. The reason is that trace 2 uses the EMI average detector. Unlike a regular average detector, the EMI average detection displays the average value of the amplitude envelope, rather than the average value of the sample detected amplitude. It is defined for EMI measurements by the CISPR 1611 standard. We can speed up the measurement by only scanning one trace and using peak detector. If the signals pass both the quasi-peak and average limits, then the measurements pass, because, as mentioned previously, to measure the same signal, the displayed signal in peak will never be lower than average or quasi-peak. If they fail the quasi-peak or average limits, quasi-peak and average of the signals need to be measured. We only scan trace 1 with peak detector, therefore we blank the trace 2 and set limit 2 to test trace 1. We see the sweep speed is much faster than before. There are a few signals which exceed the limit lines and the delta to limit is marked in red. That means the power of these signals is greater than either the quasi-peak limits or the average limits. If the measured emissions are lower than the limit lines, a green pass indicator will display on the analyzer screen. That means the conducted emissions performance of the DUT is able to pass the pre-compliance test in terms of standard EN55022. In this case, we can see there are a few signals above the limit lines. This means the quasi-peak and average of the signals need to be measured and compared to their respective limits. We set the CXA signal analyzer to search the signals which are above the limits and measure the power in 3 different detectors: peak, quasi-peak, and EMI average. Now we can start the scan. We can see that all the signals above the limit lines are measured and placed in the signal list with the following information: frequency, amplitude in 3 different detectors, and delta to the limit lines. Now we can review the measurement results. The QPD delta to limit line 1 and EVE delta to limit line 2 should all have negative values. If some of the measurements are positive, then there is a problem with conducted emissions from the DUT and diagnostics corrective action should be taken. The signal list and frequency and amplitude data can be a good reference during diagnostics. The CXA signal analyzer can also generate the detailed measurement report in an HTML file. Which can be opened by Internet Explorer for post-analysis. After the measurements are completed, we need to disconnect and power off the devices. It's recommended that the signal analyzer be disconnected before powering off the DUT, because this action often creates high-level transients. We want to make sure the analyzer is not impacted. To summarize, for this demonstration, we've used the N9000A CXA with EMI measurement application. A limiter and a listen, this configuration is the most cost-effective X-series signal analyzer solution for performance conducted emission testing both commercial and MIL STD requirements, and is a valuable tool for helping to ensure devices pass costly EMI conformance testing. The CXA is part of Agilent's X series of signal analyzer and is the most economical model. Other available X-series solutions feature the high-performance PXA and the mid-performance MXA and EXA. All of the X-series signal analyzers offer a combination of measurement sensitivity, accuracy, and usability, and can run a variety of measurement applications, making each model a cost-effective laboratory tool as well as an EMI pre-compliance test solution. For more information on conducting emissions tests using CXA, EMI measurement application, and probe set, please visit www.agilent.com/find/CXA-EMI.